exist 10, 15 years ago. There is a demand for science programming if it's done well. But on the other hand, where are the scientists out there that can then tell people how important it is, why they should appreciate science, and why they should fund science with their taxpayers' money? And part of it is habit. During the Cold War, we were spoiled. We got our inventions, our machines. We would go to Congress and basically say one word. We go to Congress and say, Russia. And then Congress would whip out a checkbook and say, how much? That's how we got our atom smashers. That's how we got our big machines. That's how big science was funded. Well, Congress figured it out. Russia is not building gigantic machines anymore, and we can't use the excuse of the Cold War to get our budgets funded. Now we scientists have to learn how to communicate directly to the American people. We have to, quote, learn how to sing for our supper, or else they're going to cancel our super colliders, or else they will cancel our machines. Now, sometimes in the scientific world, they say, well, don't engage with the public. They're ignorant. You'll be misinterpreted. It's not worth it. But hey, let's face it, your budget's going to get cut unless you can tell the American people why the taxpayers' money is going for good causes, why it will cure disease, why it will solve the mysteries of the universe, give us new exciting technologies. It's up to us to get into the political fray.
Michio Kaku, you write in Visions, in the U.S., the best scientific minds are often absorbed by the Pentagon, which uses their talents on new generations of weapons. Even redirecting a tiny percentage of the military budget to pure science could have a profound effect on the development of technology. What about the National Science Foundation? What about our system of national laboratories? What about private enterprise?
If you take a look at the system of national laboratories, they really have done the yeoman's work of pushing the boundaries of science. But you know, hey, we're entering a new period, a period where the best minds and the funding is not necessarily going into that direction. I once had lunch with Freeman Dyson, very well-known physicist, and he grew up in England in the 30s. And he said there was a very disturbing feature of England in the 30s, that it was a society in decline. It was decaying. All the best minds were no longer going into engineering and chemistry and physics. The best minds were going into the London Stock Exchange. They were learning how to massage other people's money rather than create wealth, create chemical factories and new inventions. And then he said something which really shocked me. He said, I see it for the second time. For the second time in my life, he says, I've seen the same pattern. Just like England of the 20s and 30s with the best minds going into coupon clipping and stocks and bonds and stuff like that, massaging other people's money rather than creating wealth. Today at Princeton, he said, where he teaches, it's happening again. The best minds are going into investment banking, massaging other people's money rather than going into physics and chemistry. Well, we all know what happened to Wall Street. It imploded. The best minds of a generation imploded our economy, and we see the consequences that our scientific establishment is eroding as a consequence. Let me give you an example. In the United States, 50% of all PhD physicists are, in graduate school, are foreign-born, 50%. At City University of New York, it's 100% are foreign-born. What we're witnessing is a hemorrhaging of our scientific elite, compensated for by foreigners who then populate our PhD institutions. Now, however, as you've been reading in the papers, China is saying, come on back. The water is fine in China. We'll give you a laboratory. We'll give you whatever you want if you come back to China. Well, this is unstable. It can't last. Remember, the British began to decline when their scientific establishment began to crumble. Our scientific establishment has been maintained by a brain drain. We still get the best scientists around the world and send them to Silicon Valley. 50% of Silicon Valley, by the way, is foreign-born. 50% of the scientists there are foreign-born. But it's unstable. It can't last forever, especially because the Indians and the Chinese are saying, come on back, the water's fine. You don't have to be in the United States anymore. So I think it's a warning. It's basically the canary in the mine shaft telling us, watch out. We could go the same way as England.
Are we recognizing that? Are we funding differently? Are we encouraging differently?
No. Take a look at the media and the debate. Almost all the debate is about redistributing wealth, massaging wealth, rearranging wealth. But the question is, who is creating new wealth? Who's creating the next transistor, the next steam engine, the next light bulb, the next internal combustion engine, the next laser, the next satellite? Who are creating these things? Well, don't be surprised if one day it's going to be the Chinese and the Indians. Now, I don't want to scare people. I'm saying that you can see the beginning of this erosion today. The best minds not going into the hard sciences, but going to Wall Street, where they basically implode the economy.
And from Hyperspace, one of Dr. Kaku's books, more than half the gross national product of the Earth, representing the accumulated wealth of the planet, depends in some way on the electromagnetic force. Tucson, Arizona. Frank, hi.
Hi, Professor. I really enjoy your efforts to make very difficult concepts understandable by the layman.
Thank you.
I've got a pretty good knowledge, I think, of physics. I had a little trouble with Einstein relativity, but I think I got some of that. But I'm really having trouble with string theory. It doesn't seem to be testable, which at least, as you mentioned earlier, relativity is now a law rather than a theory. Could you help me out in understanding string theory?
I'd be delighted to.
We've talked about it a little bit, but if there's another twist that you can put onto it to help him, that would be great.
Think of music. If you take a violin and string, or even a rubber band, different vibratory notes on a rubber band corresponds to a subatomic particle. So if I take an electron and look at it with a super microscope, I would see that the electron is not a dot, it's actually a rubber band. And if I twang the rubber band, it turns into a neutrino. I twang it again, it turns into a quark. And I twang it enough times, and it turns into the hundreds of subatomic particles that we see in our atom smashers. So the notes on a tiny, tiny string correspond to all the subatomic particles. Physics corresponds to the harmonies governing rubber bands. Then chemistry corresponds to the melodies you can play on rubber bands that bump into each other. The universe is a symphony of strings, and the mind of God that Albert Einstein wrote about for 30 years of his life, would be cosmic music resonating through 11-dimensional hyperspace. These are not ordinary strings and membranes. They're resonating in 11-dimensional hyperspace. And then you may say, well, that's fine and good, but prove it. Well, with the Large Hadron Collider, we hope to create sparticles. Sparticles are super particles representing the next set of vibrations on a rubber band. Everything you see around us is the lowest octave of a vibrating string, but the vibrating string has higher octaves. And the next higher octave could be sparticles, which we hope to create with the Large Hadron Collider. And one example of a sparticle, we think, is dark matter. If you've been reading all the cosmology websites, you know that dark matter is invisible matter, but it makes up most of the matter of the universe. The universe is not made out of atoms so much. Every chemistry book is wrong. Every chemistry book says the universe is made out of atoms. End of story, period. Wrong. The universe is made out of dark matter, and we think dark matter could be a higher vibration of the string, and we will create dark matter, we hope, with the Large Hadron Collider. So all theories are testable, including string theory.
In Parallel Worlds, you write that 73% of the universe, or the cosmos, whatever, is unknown energy.
This is embarrassing. If you want to win a Nobel Prize, explain what is dark energy and dark matter. Now, we think we're so great. Atoms of oxygen, carbon, nitrogen, we think that's the universe. The atoms of our body, the higher atoms, make up 0.03% of the universe. Let me repeat that again. 0.03% of the universe is carbon, nitrogen, oxygen. 4% is hydrogen and helium. The rest, 96%, is dark matter and dark energy.
Why don't we know? Why don't we know what it is?
because it's not made out of the familiar atoms that we can see and touch in our laboratory. They're very elusive. If I have dark matter in my hand right now, it would be first invisible. Second, it would filter right through my fingers, go right through the floor, go all the way to the center of the earth, and all the way to China. Reverse direction in China, and then come all the way back to my hand. Have you ever seen that before? That's what dark matter can do. And the Earth moves in a wind of dark matter, and we're going to try to measure that wind with our machines. We have gigantic vats of hydrogen fluid that we hope to detect the wind that we are moving in. So this is big science, multi-billion-dollar experiments, the Large Hadron Collider, experiments on dark matter. This is the cutting edge, realizing that every chemistry book is wrong. The universe is not mainly made out of atoms.
Dr. Kaku, when people read about the LHC in 100 years, will they think, oh, that's quaint? Oh, apple falling on Newton's head?
Yeah, they will definitely think it's quaint. That machine is, what, 27 miles in circumference. It's probably bigger than the city of Geneva. You could put Geneva inside the machine. And we will think it's quaint because in the future, we hope to create what are called tabletop accelerators. They exist on a small scale, but in terms of energy input per meter, we can get machines that are only a few meters long that will accelerate particles to billions of electron volts, once thought to be impossible. So perhaps in the future we'll have tabletop particle accelerators.
Next call for Dr. Michio Kaku, who is our guest this month on Book TV's In Depth. Todd in Wixom, Michigan. Hi, Todd.
Hi. It truly is an honor to speak to you, sir. You answered one of my questions about the time travel, but while you were speaking, I got a comment and possibly a question how you personally feel. It's amazing how far man has advanced technologically, but it's also amazing how little he himself has changed. Now, I remember you saying that you were a Star Trek fan, but as I recall, in order to achieve membership in the international space community, they had to overcome greed and capitalism and social injustice and all that so they could concentrate all their efforts on moving forward. Now, my personal question to you is, what at this time is more important, social equality and helping your fellow man or technological advances? Thank you.
You ask a very good question. What is more important, helping society get richer and wealthier or scientific experiment? Well, you can't divorce the two, because where does wealth come from? Where did the transistor come from? The laser beam, the GPS system, the internet, the steam engine, the light bulb. These are sources of every technology you see around us. The wealth of nations, the high standard of living that we enjoy today is a direct byproduct of the steam engine, the laser, the transistor, the computer. So science is the driving force that makes possible the elevation of society. Realize that just a few hundred years ago, we had a tiny percentage of human population being kings and queens and nobles, and about 99% of the human population living in an abject poverty, grinding, back-breaking poverty. That changed with the coming of the steam engine and the Industrial Revolution, and that helped to create a middle class. So the middle class that we are witnessing, for example, growing in China right before our eyes, is a direct consequence of the technology, the inventions, and the Chinese are very clear about this. Why are they sending all their PhD students to America, where I see them? In fact, one of my graduate students was, in fact, Chinese. Half our physics department is foreign. 100% of our physics department is actually foreign-born in terms of the PhD program. So the Chinese understand this. They make no bones about it, that they want to get as much of science and technology because the West, lives off its laurels. They know, the Chinese know, that this is going to be the source of their wealth. It's a meal ticket to the future. Now, you also mentioned the fact that we are very backward socially. And part of that fact is that our brain, our personalities haven't changed for 100,000 years. 100,000 years ago, the best evidence shows that modern humans that look just like us, you give them a haircut, a three-piece suit, put them on Wall Street, they look like all the other barbarians on Wall Street. People just like us emerged from Africa 100,000 years ago.
Private enterprise.
If you take a look at the system of national laboratories, they really have done the yeoman's work of pushing the boundaries of science. But, you know, hey, we're entering a new period, a period where the best minds and the funding is not necessarily going into that direction. I once had lunch with Freeman Dyson, very well-known physicist, and he grew up in England in the 30s. And it's up to us to get into the political fray.
Michio Kaku, you write in Visions, in the U.S., the best scientific minds are often absorbed by the Pentagon, which uses their talents on new generations of weapons. Even redirecting a tiny percentage of the military budget to pure science could have a profound effect on the development of technology. What about the National Science Foundation? What about our system of national laboratories? What about...
Or else they're going to cancel our super colliders, or else they will cancel our machines. Now, sometimes in the scientific world, they say, well, don't engage with the public. They're ignorant. You'll be misinterpreted. It's not worth it. But hey, let's face it, your budget's going to get cut unless you can tell the American people why the taxpayers' money is going for good causes, why it will cure disease, why it will solve the mysteries of the universe, give us new exciting technologies. Exist 10, 15 years ago. There is a demand for science programming if it's done well. But on the other hand, where are the scientists out there that can then tell people how important it is, why they should appreciate science, and why they should fund science with their taxpayers' money? And part of it is habit. During the Cold War, we were spoiled. We got our inventions, our machines. We would go to Congress and basically say one word. We go to Congress and say, Russia. And then Congress would whip out a checkbook and say, how much? That's how we got our atom smashers. That's how we got our big machines. That's how big science was funded. Well, Congress figured it out. Russia is not building gigantic machines anymore, and we can't use the excuse of the Cold War to get our budgets funded. Now we scientists have to learn how to communicate directly to the American people. We have to, quote, learn how to sing for our supper.